us take one more example in this regard, please. Suppose if the length of the pendulum is very large, he will tell you few kilometers or very high value he may give. So, what would be the time period of that pendulum? Time period of a pendulum of larger length, that is the concept, larger length. So, you can remember this formula 2 pi under root LR by G into L plus R. This larger length I am considering that one as L, and we can directly understand in this case the value of R is once again radius of earth. Radius of earth means 6400 kilometer, that is a known value to all of us. So, this is the equation we can understand for its time period, and frequency when we want 1 by 2 pi G into L plus R by LR. This is the equation for its frequency. Based on this one, they can ask us one question: what would be the time period of a pendulum? Time period of a pendulum of length equal to the radius of the earth. What would be the time period of a pendulum of length equals to the radius of the earth? That in the sense we can say L is equal to R in the above equation. Therefore, what would be the formula for its time period? It is 2 pi under root, this L is equal to R we can write, directly we can take up that matter here. So, this becomes R square by 2R, R gets cancelled, R by 2G you will be getting. So, what is the corresponding formula here for time period? 2 pi root R by G, already we have discussed earlier. In that context, if the length is infinite, but here length is equal to radius of the earth, 2 pi root R by 2G, and exactly in the same manner I can consider the frequency as 1 by 2 pi under root 2G by R. In both the cases, one can understand the value of R, which is 6400 kilometer or 64 into 10 to the power 5 meter as such, and G roughly you can take it as 10, actually 9.8 we know that. To know its rough value or estimated value, just like that you can take the value of G as 10 and you can complete the calculation part of it. So, this is one more case one need to remember. Let us take an application of simple pendulum when charge is given to the bob of the pendulum. One example let us take here. There is a pair of plates like this. This plate is having positive charge on it. This plate is having negative charge on it. So, simply speaking, I just have applied uniform electric field between these two parallel plates. A simple pendulum now is made to oscillate simple harmonically in between the plates, giving positive charge to the bob. What is the charge that has been provided to it? I consider that charge as Q. Which Q it is to be remembered? It is a positive charge given to it. Then definitely we will be finding, since it has got mass, it will be acted upon by weight downwards. In addition to that one, there will be a force due to this electric field. If I consider electric field strength or strength of electric field as E, then I can write the force on this bob becomes EQ. So, how many forces they are acting on this bob now in the downward direction, and how many forces they are acting on the bob in the upward direction? There will be tension acting upward and two forces, one is mg and one is EQ, both are acting downward. Now, in this particular case, what we should understand is when both EQ and mg are acting downward, then we can understand the resultant acceleration now becomes g plus EQ by m, because EQ becomes a force, force by mass is acceleration, we know that. So, this is the acceleration due to the applied field. This acceleration due to gravity is very much acting on that bob. So, what would be the effective or resultant acceleration of that bob now? It is g plus EQ by m. Therefore, the time period is equal to 2 pi under root L by g plus EQ by m. This is the formula by means of which you can calculate the value of time period. But one thing you definitely can understand from this formula, time period decreases because the denominator is increasing here, then automatically the value of time period decreases. Not only that, usually whenever we consider time period of a simple pendulum, t is equal to 2 pi root L by g, when we consider, it is independent of its mass. In general sense, time period or frequency of oscillating pendulum, they are independent of mass. But when you apply electric field on the bob, given positive charge, then you will be finding the time period is even depending on its mass there. So, this is the time period equation. In the same manner, we can write frequency is equal to 1 by 2 pi under root g plus EQ by m divided by L. This is actually the case. So, what we can understand is n automatically increases because numerator is increasing here. So, this is the equation for its frequency. But there is no rule that every time we have to provide positive charge to the bob. When I consider the same case this way, same pair of plates once again, I have given positive charge to the upper plate, negative charge to the lower plate. As usual, a pendulum is suspended over here and made oscillated simple harmonically. Now, this time I gave negative charge to this one. The charge given to that one is Q again with a negative sign. Then what would be the acceleration? Then acceleration in this particular case, you have to remember this way. Weight is acting downward and force due to electric field is now going to act upward in addition to the value of tension. Therefore, what would be acceleration now? It is g minus EQ by m. That is the formula one has to take. Earlier we have written plus, now it is to be taken negative. So, you will be getting the time period t is equal to 2 pi under root L by g minus EQ by m. This is the time period equation, wherefrom you can say that t increases because the denominator is decreasing here and the frequency n now becomes 1 by 2 pi under root g minus EQ by M divided by L. So, what we can conclude here, frequency decreases, that is the concept we have to remember. Time period increases and frequency decreases. These two are the cases when the bob is given negative sign over there, that is what we have to understand. So, whenever the bob is given certain amount of charge, may be positive or negative, and made oscillated in uniform electric field of strength E, then how to just write the equations for its time period and frequency, one need to remember by considering both the cases as such. So, these are the different cases as far as simple pendulum when we consider that is concerned.